Nice to see you. Great chat yesterday.
Likewise, really good. Yeah.
Yeah, it was nice to talk in front of a little bit of people. Parisian Sen was not that bad. Cool. Well, welcome to the pod. We're gonna have a nice chat about everything that you guys have been up to. I'm super excited for it. Obviously, been working with you guys for quite a while. It feels like years, but it's actually not so long. And in that time, you've been through a lot. So let's get started with just maybe getting to know you guys a little bit better. Harry, do you want to get started?
Yeah,
maybe
sure.
go into your background and we can move it from there.
Sure, yeah. So I'm Scottish. I was born in Scotland. Growing up, really interested in business, basically. So, like in my early teen years, used to sell paintings online and just
Really?
yeah, just
I didn't even know that.
yeah, just generally quite quite experimental with business ideas. It became clear to me I wanted to kind of do something like in entrepreneurship. Studied a combination of economics and statistics at university. So econometrics is its kind of is a kind of key area. And then during my postgrad in the US, I basically became acquainted with machine learning, and this was about maybe 2016. So there was the original boom in neural networks, which happened in the early 2010s. And that kind of also came with some new statistical machine learning methods, or old statistical machine learning methods that were becoming much more popularized, like random forests, XGBoost, etc. And in the mid 2010s, and I remember vividly being someone coming in and giving a lecture about using random forests to classify an economic problem, and I was hooked. I was like, I want to spend the rest of my life doing this. This is going to change everything. So went back to London, and then whilst I was there, the main kind of focus was an applied machine learning startup where I led their data research team, and we basically were tasked with predicting building fires and wildfires. Really got strangely acquainted with why buildings catch on fire. I remember had to go to
Any insights?
Yeah, I think there's the most interesting one I thought is the risk of a building. If you don't have the data for the building, can actually be quite well estimated by the risk of the adjacent buildings. And it's something that you don't think about, but your neighbors affect your insurance policy. And we so when we did data capture, which was something that the team I led were quite focused on, sometimes if we could work out what the wall in one building was made of, and if it had a shared wall, and you could just use that data for the adjacent building and things like that. But yeah, I remember going to Australia and being at University of Queensland Fire Research Department, and just strange experiences. But ultimately, our team was basically taking principles which were very common in algorithmic hedge fund trading, where you would take lots of alternative data sources, model them with kind of cutting edge statistical machine learning techniques, and basically beat people who weren't doing that, and then sell those insights to the insurance and reinsurance industry. Did that for about 3.5 years when I got to the point where, I'd always wanted to kind of build something and start up that myself, kind of going back to my early years, number one. But number two, with respect to machine learning, I was convinced that, one, this narrow application that my team are working on is going to burst out this niche, and it's going to be applied everywhere. It's going to be absolutely foundational. And, we've seen that very recently with ChatGPT and the kind of rise of high performance LLMs. That's point one. And point two was we used a lot of kind of computational power, and obviously we thought a lot about data, and it became clear to me that those were going to be one or both of those areas would be the bottleneck for progress with it becoming generalized. Quit my job January 2020, which was immaculate timing. And the kind of goal was I had some personal runway to start up a company. I was just going to kind of self-fund and think about ideas in that space, but got accepted onto the Entrepreneur First program in London, which, for those who don't know it, is essentially a marriage of Love Island and Shark Tank. So you arrive as an individual and you try and find a co-founder in the accelerator. Everyone's had to quit their jobs. Everyone's very highly curated for the cohort. There's a bit of a kind of deep tech bend to it all, and at that point I met Ben.
Okay, so maybe Ben, you can tell a little bit of your side of the story before we jump right into what you guys did over at EF and how that birthed Gensyn.
Absolutely, yeah. So I grew up in the north of England, so physically close to Scotland, but very much England, and took a kind of pretty classic computer science path for the most part up until university. And then when I was at university, I actually did a sandwich degree where I did a year in industry, and I did a year as a database administrator and like system administrator, and essentially realized as I was doing that I really enjoyed the part at the start of that year where I was learning, but I realized that kind of like towards the end of the year, I'd learned a lot of the things I needed for that job. And then I was thinking, well, where does this go, right? Like I got offered a job, I could carry on doing that, but like I'm looking at a 40-year career and something that like I've learned a lot of the principles already, like I know how to do it. And I didn't like the idea of that. I was like, I have to keep that like learning progress because that's what like really excites me. And essentially, I went back to uni, did my final year, and was like looking at the options for how I could keep that learning process. Got involved in kind of like the Hacker News scene and like Y Combinator. Came to the Y Combinator startup school in London back in 2014. Heard about Entrepreneur First, had a chat with them at the time, and then I was kind of considering my options, looking at entrepreneurship, and then got the opportunity to do a PhD. It was never anything I'd considered before. Didn't really know anything about academia beyond like a bachelor's degree, but realized while I was talking to people about it that represented a very similar thing, right? Like you can focus on learning, you can focus on just like self-directed, going super deep on a topic and figuring out that entire topic and the space and all the things around it. So that's what I ended up doing. Did a PhD in machine learning as kind of deep learning was exploding for computer vision. So computer vision was my area. AlexNet had just sort of happened a year or two before where like you could see the power of GPUs and these like neural networks, which they'd been around for a long time, but nobody had really like applied them yet. Had been shown to be like massively effective for computer vision. So while that was happening, I was on the PhD. I was seeing all the kind of big advancements, and one of the trends that was happening at that time was people would be handcrafting neural networks for specific problems within computer vision. So you'd have this new task where you need to classify certain images, or you need to do object recognition or something like that, and you'd have a specialist who would like craft a specific neural network for that, and then they would publish that as novel research. But the kind of ecosystem itself was starting to realize that that's just one big optimization problem, right? Mm-hmm. Like the scope of the network, the architecture of the network is in a constrained space, and essentially us sort of manually designing those and then releasing them as sort of novel research started to get a bit stale. So my research area essentially focused on automating that whole process. So automate the design of neural networks themselves for tasks. The thing with that as a problem is it's incredibly computationally expensive. So you take the computational kind of complexity of training a neural network, and then the way I was doing it was with swarm algorithms, where you train 50, 100, 300 of these networks at the same time in parallel, all together in order to get this kind of meta network, which would be really performant. So it kind of compounds the computational power required to do it. And one of the things that was very frustrating to me was I had a little bit of research funds to buy GPUs. So I had 4 GPUs under my desk that I would do that research on, and I'd like use to run my models. And then the major labs would come out with research where they'd use 3,000 to 5,000 of those GPUs for like 3 weeks at a time. And there was just no way for me to do that. I just didn't have access to that compute power. But I did have access to all the other things needed. So I had access to the data. It was like open data. I had access to the expert knowledge, like all the kind of other researchers were publishing their methods. I had proposals of methods. I just couldn't breach that kind of compute barrier. And I realized that if I'm in that position, so is a lot of people in the world. And it means we're not progressing on machine learning as fast as we could be. And to me, machine learning AI was going to be like a huge thing for humanity. It was very, very clear that after the massive successes within computer vision, it would break out of there. It would be in everything that we do. It was just a matter of time before that would happen. And that compute barrier represented this massive slowdown that I just really didn't like. So that kind of seeded this sort of like desire that ended up being behind Gensyn in my mind. I kind of, at the same time, realized that my future probably didn't lie in academia. The incentive structures of academia are interesting. You have to, you feel free in some ways to do research that you want to focus on,
but not really.
In other ways, you're not very free. You're inside an incentive game that's a little bit different. So I didn't like that game. So whilst I was doing the PhD, I got back into the startup world, got involved in the startup space in the city I was living in, and ended up co-founding a startup alongside my PhD, which I highly do not recommend to anyone because it means you'll do worse on both things, essentially.
Dangerous, yeah.
Yeah. But it's great fun, and I don't think I would have done either of them without doing them at the same time, if that makes sense. Like it was really motivational to be doing the two. And yeah, essentially that was a kind of passion project within the data privacy space. So it was around this idea of like consumer data privacy, the rights that we have to our data, what gets done with it by these companies. I was very aware of that because being in the ML space, I could see what you could do with the data. So seeing that, you make the assumptions, well, if I know about that, then the larger organizations are doing that. And then if consumers aren't aware, then it'd be nice for us to move to this future where consumers are more aware and more in control. A lot of people have had those ideas and kind of pursued that with a startup for a couple of years. Got to the point where I realized that the kind of products we were building weren't leading to that like ideological future. They were much more like kind of SaaS projects for like GDPR administration. It becomes like a regulatory play, and I realized that wasn't really where my passions lay. It's not what I wanted to do. So shut that startup down, and similar to Harry, joined Entrepreneur First with the idea of meeting a co-founder who had the kind of same like drive as me to build something massive, and also that same like deep interest in how big ML and AI could be for the world, as long as we can remove some of those barriers. And like Harry said, the barriers to me were data, expert knowledge, and compute, and that was where we got started essentially.
Okay, so you're in on Love Island. You're hanging out there. You met each other. What was beyond the ideological alignment? What made you guys really vibe with each other as co-founders and decide to take that step forward and build a company together?
Sense of humor.
Yeah.
Sense of humor.
It's that vibe, like you say. It was a vibe. Yeah.
Okay.
Yeah, I think the one of the most underrated traits, which is something because now we kind of mentor people on the same accelerator that we were on. One of the, I'd say it's in the top 3, maybe the top 2 area like things is you just have to be able to laugh with each other. Because we've gone through some pretty like hair-raising times, like, you know.
And I know your humor. You guys can get pretty dark.
There's a darkness about like England and like a literal darkness, and also like a kind of figurative darkness about like the north of the UK, which I think is kind of conducive to having a certain type of humor. But having a shared sense of humor, being able to laugh at things. I mean, you know, a good like case in point, you know, just to fast forward to 3 years, raising our Series A, during the fundraise, our bank collapsed. So all the kind of runway we had was in I won't say which one it was, but it was one of the banks that collapsed earlier this year. We got it all out, but there was a brief period of time where we basically just, you know, it went to zero.
It was a fun weekend.
Yeah, and that was over a week.
You guys had a lot to laugh about.
Yeah. No, I know. It's kind of like laugh and cry, but no, like being able to kind of, you know, take on extremely serious and kind of foundational topics, but also, you know, not letting the kind of stress get to you is the kind of core thing, and I think humor is possibly the best and maybe only vector to do that. So yeah, we're on Love Island, so to speak, and we meet each other very early on. And basically, as Ben said, we share that kind of thesis around building something very foundational in the machine learning world. We have a kind of complementary skill set. So we've both done kind of commercial things and technical things, which is like kind of rare in founders. There's usually like a more kind of clean split between one and the other, but we found it very complementary. We kind of felt like a shared sense of gravity emerged between us, whereby we sort of were kind of almost like one entity. So we quickly basically retired the idea of having a CEO and CTO split, and we just went with the kind of cleaner co-founder title, which is actually quite heterodox. Like most people don't do that. And it's a question we got asked in various funding rounds, but it's something which has worked really well for us, and also promotes a sense of kind of autonomy, I think, in the wider team, because it leads to like a flatter structure in general. So yeah, that's the that was a kind of origin. Of course, we met each other very early on. COVID happened, which was kind of crazy. I remember at the time, people around the accelerator were saying, this is going to be like one of the worst times to raise money ever. Market's going to go to zero. Like it's, it's a horror story. Ended up, of course, being one of the biggest bull runs ever.
Who would have thought?
Yeah, exactly. And really, it's a pretty overdone kind of point now. It pushed forward technology quite significantly in terms of adoption. People were forced to adopt it. So we ended up spending, like 10 hours a day on Zoom calls, like talking to each other because we had to be fully remote. So we were born basically as a fully remote company. But the principles never went away, and they became more and more kind of I guess prescient in wider society. Things were becoming digitized. People were relying more on machine learning. Classic examples of it were, the way in which people were now having an over reliance on automated tools and the internet, etc. It became clear that timelines were accelerating.
So timelines aligned actually perfectly for you guys when it comes to raising funds, when it came to finding the right partners, building a team. Let's just talk through that real quickly. What was the thing that really gave birth to Gensyn? So you're out of Love Island. You've decided to really take this thing forward. What happened from there? And just maybe let's go through the journey of the really early days of Gensyn.
Yeah, I think it's interesting to note that Gensyn, so when we talked about the kind of wanting to build a big distributed foundational machine learning infrastructure, we actually started looking at some of the data problems. So around kind of like why there's silos of data in organizations and how like it's hard to do machine learning and model over those silos. And some of the kind of experience we'd had in the privacy space sort of fed into that. And essentially, we started building these tools to do machine learning over those data silos in large organizations because we thought this is a valuable problem. We explored that for quite a while, and we had some success with banks and things where they've got these problems. But there's a kind of current running alongside that all the time, which was everyone we knew in AI and ML was talking about compute. They were like, this is my biggest problem. You talk to them about the kind of data issues and like, oh, can you model over all the data you've got access to? And they'd be like, oh, not really. I kind of can. Like, yeah, it's a bit of a problem. And then they'd go on to compute and they'd be like, but the real problem is the fact that I can't get any GPUs. And for a while, we sort of like ignored that and stayed on this path of like, okay, this is the problem we're solving. But it got to the point where we're like, we can't ignore that anymore. Like that is the problem that we both felt like it's an indisputable problem, and we're being kind of bombarded with people talking about it. And then we thought, well, the infrastructure we're building, it's like moving models around and send them to different places and then like recombining the results and things like that works over compute. There's no reason why you can't do it over the GPUs, the TPUs, the CPUs, and things like that. And then we thought, okay, well, what if we can solve the compute problem with that? The big thing with solving the compute problem is you want to make it the kind of largest scale you can possibly make it. You want to properly solve the problem. In order to properly solve the problem in our minds, you had to be able to essentially connect up every single source of compute in the world. It's not like, oh, let's build a bigger cluster or let's like connect up 2 clusters. It's like, how do we connect up everything, like absolutely everything? And for us, that was when we sort of thought, okay, let's focus on this problem. Let's go into the research. Let's figure out like how you do that. We got into like verifiable computation research, which is like, okay, I don't trust this GPU over here. How do I send a task to it and get the results back, trusting it? And that's within verifiable computation. That's the big problem. There's a kind of truism in there, which is there's absolutely no way to do that without a trusted third party. You have to have somebody else who can check that work. So we went kind of deep on that, realized that problem, and then realized there's been a few people looking at this, right? Like there's a certain space which looks at the idea of what if a trusted third party could be a group of people. And that was the light bulb moment for us, that it was like, okay, this is what blockchain and the crypto space, like the technology behind it, that's what it solves. And that was huge. Like we'd obviously both been very aware of the crypto space. Like we'd kind of dabbled a little bit, being technical, you play around with it. But to be honest, we'd both kind of avoided it. Like it just hadn't really been on our radar. It had not been something we dived deeply into. But I think for both of us, when we realized that technical solution, we were like, oh, this is incredible, right? That this changes everything. And then from there, it was just like focus. Okay, how do we use that principle that the consensus of a group can be a trusted third party in breaking a dispute over a computation? How do we use that to build an ML compute network? And that's basically all Gensyn's been thinking about ever since. Like that's been the core goal of the company. And we've had different proposals for how to do that. We've had them change over time and kind of evolve to the point we're at now, where we have this solution. And now we're building that solution and planning to release it. And that's been kind of like the big journey. But yeah, it's
something that's interesting is a lot of machine learning kind of native people view crypto with a certain degree of skepticism, I think. Like, we certainly did. Even if they have very aligned principles to, I guess, the kind of more like cypherpunk roots of crypto. Like, so obviously Ben's background in privacy was relatively aligned. I was really interested in censorship resistance. There was also just this kind of through line of the kind of, we'd call it like the right to build. So this kind of, we were both attracted to this idea of kind of self-sovereignty online, as opposed to these sort of, these like vampire squids, which are like wrapped around the world, owning everyone's kind of data, being able to kind of just switch people off, basically owning all these transistors. It going back to that kind of more patchwork, like Web 1 world, which we grew up with, was really attractive. But, when you think of, at least like back then when I thought of crypto, I kind of immediately associated it with the more kind of like financialization of, online spaces and things like that. But really what a lot of people miss is like, if you just kind of hold your breath like a little bit longer, there's this huge body of fascinating and a highly relevant, verifiable computation work, which goes on, under the surface.
And I think some of your points there touched on what I would call just basic premises of human freedom, right? So I think that there's, and you guys really talk about that a lot, and the idea of the right to build, as well as computational liberty, which is both ideas that you guys have been kind of pioneering and bringing to the forefront of your messaging. But similarly to even privacy, which you've been so close to as well, there's these ideas of like, you should, as a human, be able to have access to these things, which are not supposed to be luxury goods, right? Like nobody sees privacy, or nobody should see privacy as a luxury good or as something that only the rich or the corrupt in this sense, can have access to. And I have grown to think about compute in a very similar fashion. And so specifically in the kind of world of machine learning and in our world, which is really just dramatically skewed towards that innovation now. I do kind of see some similarities there. And so how do you think about this kind of idea of the right to build, the potentially the more philosophical arguments for opening that up?
I think a lot of it kind of came out of people in the kind of 15th, 16th, and 17th centuries, like John Locke, like the homesteading principles, etc. Like if you read things like the Second Treatise of Government and think about it, there's just kind of like, there are these two conflicting concepts of like negative liberty and positive liberty, where negative liberty is like, there's no one who's kind of stopping you from doing something. And then positive liberty relies more on this kind of like, almost like social contract-esque idea where there are rules saying what you can do, And I think personally, and ultimately we think about it from a negative liberty perspective, as in you start with kind of these natural rights, and one of the most kind of widely accepted one in Western society is free speech, and free speech, over time has evolved from someone needing to like remove your tongue from your mouth if they want you to stop talking to basically limiting your access to certain, silicon, to certain transistors if they want to stop you from docking. And similarly, if you take kind of these beliefs that, code is speech, your ability to basically write something down, because I mean, code, it's very similar to speech in many ways.
It's expression, right?
It's expression, yeah. It shouldn't also be limited. Then you get in this kind of weird world where if you think about the way that, say the European Union's thinking about artificial intelligence as of, today and in summer of 2023, we have the draft, EU AI Act, where there's ideas in there about, the government banning facial recognition systems, but not banning them in certain cases where the government deems them to be permissible. And that starts to get really, really close to the idea of basically banning speech for people, but not for kind of vested interests. And that's maybe more of a kind of government approach to it. But then we also see, large companies around the world endorsing the idea that there should be a slowdown in AI research for various concerns, which, you know, cynically is for perhaps commercial reasons because it prevents other people from catching up with the big gains they've already made. So there's this kind of concept around people trying to put in new laws to prevent people from being able to compute and having a right to build. And to us, that's essentially incongruent with the concept of computational liberty. Computational liberty is our bodies, our brains, ultimately are at present organic, and you know, the compute's all organic in our head. Like the neural networks that we build are, you know, right now they're artificial, but in our heads they're organic, and we're going to move from organic to artificial probably at some point in the next kind of 2 decades, where brain machine interfaces basically meld the two together, and it gets very close to being, you know, a limitation on what you can think if people start to say what you have the right to and, you know, not to build in the artificial neural network space. So to summarize, we think that there shouldn't be limits on what people can, you know, create in terms of models. That's kind of the foundation. There's maybe an argument further up the stack when it comes to the application layer.
Yep.
Like, you know, if you've got like certain, you know, neural networks which are generating content and there are children in your house, yeah, you should have like the right to kind of, you know, filter them or whatever. But to say that like a person can't perform certain, you know, mathematical operations or kind of write certain lines of code is inherently tyrannical, you know. That's kind of point one. And point two is it's not dissimilar to the kind of attempts to and the ongoing attempts to regulate encryption. Like, you know, in the 90s and early 2000s, they were trying to kind of classify it under various like munitions acts, etc., and things like that, you know, where they're trying to equivocate things like elliptic cryptography of gunpowder and everything, you know, because under the idea that it was a national threat. And, you know, it can be used by bad actors, but ultimately it should be in the hands of the people. That's what we believe.
I think there's always a drive to limit tools in those situations. It's like we've created this tool and it's highly powerful and impactful, and it allows people to do a lot of things, or potentially do a lot of things in a more efficient or a more kind of like powerful way than they could before. And then there's a jump to say that, hey, we should limit those tools because people can now do these things. But we definitely firmly hold the belief that you shouldn't limit those tools. Like if we can level up human communication in some way, we shouldn't then put in limitations to stop something which is a social problem down the road, right? Like we should deal with that in a kind of social governance way at the root cause, at the place where it's actually taking effect. And I think, like Harry mentioned, with governments, that's a constant sort of ongoing fight, right? Because it can be an easy way to control things, to go after the tools. But realistically, as has been shown over and over again, particularly with encryption, that's not the right approach because it limits so much else in the world. It also hands far too much power to a small group of people, which, yes, that small group of people might be making the right decisions now. But there's no guarantee that that small group of people will continue to make the right decisions, and we don't want to hand that much power to that group. But I think we've seen the same thing happen in the private sector with, particularly around data with like social media, for example, where we as consumers gave up a lot of power to those organizations by giving them our data in exchange for using these platforms and these products. And I think we didn't realize at the time what we were doing when we did that. And essentially, it's because the way those companies build themselves, they're very centralized. They're profit-making companies. Their incentives are to continue to make profit and to continue to make more profit. In order to do that, they have a lot of things at their disposal, and those things might not necessarily align with what the consumers themselves want. And then that's when we get this disconnect where your data is being used for something else, or you're being kind of marketed to in a way that's not actually in your interest at all. But if it makes money over here, then it's fine. The way to kind of combat that in our view, and is something we realized after we entered the crypto space, is if you build those tools in a decentralized way, you don't give anyone that power. You don't give that incentive to exploit the kind of base resource to anyone. It stays this decentralized thing, and it just stays as like a technology, a tool. That's it. But it's a tool that everyone can use in different ways. And yeah, some people will be locally incentivized to use it in a certain way, but others will be locally incentivized in a different way. And those incentive structures are kind of all existing at once, rather than one kind of very large entity having this incentive that's different to the incentives of the consumers of the platform. So we firmly believe that's a better way of building tools and technology. And we think that the same thing has happened with compute, right? Like a lot of large organizations now own a very large share of the compute supply of the world, and they're able to pick and choose who gets to use that. They can choose the preferred customers. They can choose their pricing because they've got an oligopoly over the entire space. And that slows us all down. That stops other people from doing things. But that's the kind of price point. Like it just prices out a lot of people, which if you can build a decentralized version of that, then you can give that access to everyone. You build a much freer market over it. But it also limits the kind of the models we build themselves. Like it instills certain biases into those models. So if a very small group of people are able to build models, then they're going to build models in a certain way. And everybody has biases. They're going to put their own biases into those models. That's bad when only a few people can build them. We think a lot of the discussion around AI alignment and things like that that's happening at the moment, there's a kind of huge irony to the fact that a lot of the approaches to solve that are to put in more regulation, to control and kind of minimize the number of people that can build these models, because that makes the problem worse. It instills more bias into those models. Our view is the solution is to make more models. Like it's to give everyone access to the ability to build models. Therefore, if you come along and you look at all the models that exist and you're using them and you say, hey, this model doesn't represent my cultural values, instead of having to kind of lobby that organization or go via a government to get things changed, you just make your own model or you use a different model. And then we get to this kind of future where when you come along and you want to use a model, you just look at the entire space. You say, do any of these reflect my values? Maybe they don't. Okay, I'll build one and people will use it. And then through our usage as a kind of whole society, we'll sort of vote on the models that represent people. And there'll be lots of models existing. They'll come and go as cultural values change, but we'll have this kind of rich ecosystem.
And there will be inherently there's when there's competition, there's alignment in a sense, correct?
Yes.
And so maybe do you believe that there's with the absence of decentralization in this world and the world of compute specifically, do you believe that in a sense limits competition?
Yeah, totally. I mean,
Yeah,
if you think about it from like the idea of the tyranny of the majority, which is like a common like criticism of democratic systems.
Yep.
Even if you had like consensus, a 51% consensus that in a very divided country, so say like United States, which is increasingly politically polarized, if 51% of people said we want a model which interprets these things to be facts, and the other side were, well, I don't think they're facts, but there's a majority consensus, you basically end up with a model which doesn't reflect people. And this isn't a commentary on what's real and what's false. It's just the ability to have kind of your beliefs enshrined in the world around you. So for example, certain people will send their children to certain schools. They'll read them certain books, they'll do certain things. We're now reaching this point where the concentration of compute power and talent density within certain organizations has controlled a fundamental technology to the point whereby they can dictate, what a large language model is going to spit out, essentially what's going to be read to children, what generative content is going to be available on Netflix. There's so many areas of life into which this permeates, that to just say that, well, we've ended up with like a group of people who kind of have rough consensus from other groups of people, and they're allowed to basically have the last word on what's right and wrong is incorrect. And that's also why some of these the kind of oligopolist kind of criticism, but there's a wider criticism around governments who might say, well, we believe that this should be enshrined in the model. We as a country have these values and they should be, reflected if we're going to build a national model. And as a consequence, it's going to make these predictions. That's also kind of, problematic to an extent, because there are people with very, very opposing views in every society. And as you mentioned, that creates a competition of ideas, which has generally been productive in liberal democracies over the last 500 years. But you lose that if you just let one person hold the keys. And I think the kind of idea behind computational liberty and the right to build is to, hand that back to people. It just so happens that that's a benefit of approaching this problem with a machine learning compute protocol, which is what Gensyn is.
So let's dive into that.
Yeah.
Right. So let's talk a little bit more about really where Gensyn fits in this kind of harrowing picture.
Very bleak so far.
Dystopia.
Yeah. I mean, there has to be a kind of clean and pretty line within this entire kind of disastrous scenario that very well might actually become reality, simply because of where a regulation and where current markets and the big tech companies are angled, right? So
Yep.
we've seen the dangers. We're already talking about the dangers, and something that I think I picked up on from something that you said, Harry, is that the overregulation is only going to make it worse in a sense, because it's only going to decrease the number of folks that can actually go and compete in this market. So what we're seeing here is actually a market is far from free, far from open, and severely limits the ability of smart, intelligent folks to actually go and create within this space. And so, of course, the worst case scenario is disastrous. The best case scenario is not so good either. So let's talk about opening this up with decentralization. Let's talk about the value of decentralization within Gensyn. Specifically, maybe before we do that, what does Gensyn do? How do you guys solve this problem?
Sure. So Gensyn is a decentralized machine learning compute protocol. In the simplest sense, it connects up any machine learning capable compute hardware in the world and allows anybody else to use that hardware. So instead of accessing compute hardware via a major cloud provider, you're kind of renting from Amazon or Google or Microsoft, and you're kind of paying those oligopolistic fees that we talked about to those suppliers. You can access any GPU or TPU or CPU or any kind of machine learning capable compute device. And you do that via this verification mechanism that we kind of alluded to before. You can send a task out over our network, over the Gensyn protocol, and it can be distributed to any subset of the world's kind of machine learning capable compute. In the early kind of stages, that's GPUs, as it is right now in machine learning. But long term, that can be anything. One of the things we're particularly interested about is like the new chips from Apple, where the M1 and M2 processors are very, very good at machine learning work. There's a lot of MacBooks in the world, and they're sitting idle a lot of the time. That's a really interesting resource, but it doesn't have distribution. And it doesn't have distribution for kind of reasons around the verifiability. Like if you wanted to put a data center together and put a lot of hardware in it and then rent it out to kind of speculate on this market, you'd have to go out and find these customers who are doing machine learning work. You'd have to kind of rent them time on the GPUs and the CPUs and things. You'd have to have SLAs and contracts with them, and it'd be this kind of whole complicated process. If you can programmatically verify that the work's done correctly, you don't need any of that anymore, because essentially the smart contracts are the contracts, right? Like it's all being settled programmatically on chain in this kind of like instantaneous way. And that's what Gensyn provides. So we build an infrastructure where the work is verified on any GPU, and then the payments are made and facilitated by the chain. It's all secured by zero knowledge proofs, probabilistic checks, and game theory. It's a complicated thing to build, hence why it's going to take us a while to build it. But we believe it's like a pure infrastructure that has to exist, and it changes machine learning compute from this sort of like massive capex resource to this commodity that's just available. It's almost like the way we think about it is electricity, right? It's like electricity can go into every building and into every home. Machine learning compute can be available to every building and every home. It just becomes this ephemeral network that's wrapped over every compute device. And when you need access to it, you just send out over the protocol. It's very similar to how Harry mentioned before, like the kind of Web 1 protocols that we used to, that we all grew up with. It's similar to that. You're just sending something out over the ether, and it'll go and kind of be performed wherever you need it to be performed. And nodes can drop in and out of the network as and when they need to. So it basically creates this distribution that's seamless over all of that compute hardware. The kind of the big selling point of that from our perspective is essentially the price and scale points that we talked about. Mm-hmm. So once you create a free market over this resource, you drive down prices just by the fact that it is a free market. You break those oligopolies, you provide this huge distribution, and you say, hey, everyone can now access this. And there's an incentive for that, the auction mechanism within that, to drive down the prices massively. It then increases the scale that people can access. Right now, you're limited by various things. You're limited by price. You're limited by being a preferred customer of a major cloud provider. You're limited by the way we build models themselves, because that's developed along these lines of, we have access to a lot of compute in a data center, and that's what we'll use. We won't go outside of that because there's maybe some latency issues and we don't need to. We've just got this data center. But as we've seen with the scaling hypothesis behind machine learning, that's not broken yet. Like more scale equals better models. Mm-hmm. We're now in this kind of arms race where adding a few more GPUs to a data center is kind of like way you improve a model. But that becomes more and more and more expensive as you sort of grow. What we want to do is cut through all of that and say, okay, instead of adding another 1,000 GPUs to a data center, let's just unlock all of them in the world and let people use them. And via Gensyn, if you're willing to pay the fair market price for that commodity, you can have access to as many GPUs, TPUs, whatever as you want. You can build a cluster over everything if you need to. And that's pretty exciting. It kind of changes the way we look at machine learning away from this, like, I have to understand the infrastructure and kind of manage the GPUs myself, to this is just a resource. And like, I'll just access as much of that resource as I need to at any point in time. And yeah, that gets into a lot of really forward-looking things that we can talk a lot more about, which is like, when right now humans are the ones doing that. Humans are the ones that are sending models out and they're training them and they're kind of crafting them. A lot of what my research was in the past was automating that process. And what we get really excited about at Gensyn is what happens when we start switching to machines doing that. And we don't think that's very far away. Crypto networks and blockchains themselves offer a way for code to be an economic agent. So a smart contract on a blockchain is an economic agent in its own right. By some legal definitions, it could be a person, right? Because it can transact with anybody else in that system. It doesn't matter if the anybody else is a person or if it's a smart contract as well. When you combine that with these intelligent models that are able to generalize really well, you start building this system where it's kind of indistinguishable who's human and who's a machine. It doesn't matter. If the resources are available, a machine can trigger the training of another machine or itself. It can grab access to resources when it's made some money. It can run inference. It can earn money for doing that, and it can train itself even further. We think that is the path to true AGI. It's these economic, completely autonomous agents existing out on this substrate of infrastructure. Gensyn is the computational infrastructure for that. It's the compute resource itself, but there are other resources that are required. And that's really interesting within this space because we're seeing that happen, like in data and expert knowledge, the incentivization of all of these things, building layers over the top of them. Once all of those exist, there's nothing that can stop that kind of future of agents building themselves, training each other and growing and growing. But right now we've got these very centralized, very large models as kind of like the success of machine learning. That's definitely going to change. It's going to be lots of smaller models all existing together and interacting with each other.
And when you talk about the commoditizing of compute, when you talk about the commoditizing of a bunch of different services, and of course at Eden Block, what we've done really is invested ceaselessly into very similar systems that are decentralized systems that form two-sided marketplaces where the demand and the supply side are able to congregate and actually produce these services sustainably and actually in a way that is cheaper and even more performant than many other competing services in the real world, so to speak. What is the research that currently is driving Gensyn, and where are you guys in the process of actually building this thing? I know you mentioned that it's not going to be easy, and it certainly doesn't sound like it. You're working on solving one of the world's biggest problems, in my opinion. So maybe you guys could talk a little bit about what this is going to take, and where are you in the process?
Sure. I can cover it briefly, and then maybe you can jump in. But yeah, essentially we're at a kind of a phase change for Gensyn where we're moving from research to execution. So we've been spending a lot of time figuring out what it takes to solve this problem, what it takes to solve that verification problem efficiently. The kind of blockchain as the arbiter of the dispute between two parties is something that it's not too complicated to think about how you would do that for a small scale computation. When you scale that up to a very large scale computation, it's quite difficult. Like the chain itself can only do a certain size of computation. And when you break that dispute, eventually you have to do some size of computation. A lot of the research that we've done has essentially been to take one big, massive machine learning, non-deterministic, state-dependent computational task and whittle it down into something that can be proven to that chain. And we've done various different kind of ways of doing that. There's probabilistic research, there's converting it into a deterministic computation, and then there's like zero knowledge proofs on top of it. The ultimate kind of solution from our perspective is a combination of all of those things. So you can use zero knowledge proofs in certain instances to prove the inference of a model. And by doing that, you can learn a lot about how the model's training. By learning a lot about how the model's training, you can then target audits on top of the training process itself. You can go in and check those audits with another party off-chain, and the chain can arbitrate a dispute between those parties, and you can whittle down computations and things ultimately to something the chain can do, and then the chain has that kind of final answer, and the chain can say, you were right, you were wrong, and we can kind of go on with the rest of the task. Outside of all of that, it's financialized. So payments are being made, and people are staking amounts to say, hey, I'm going to take this role, I'm going to do this. This is my kind of bond to do that. And they can be slashed if they misbehave, and that kind of game theoretically secures the whole thing. A lot of these concepts have kind of been singularly used in other chains, but we're the only people kind of combining them and applying them to machine learning compute specifically. One of the big principles behind Gensyn is the idea of a thin protocol. We don't think a general purpose compute network makes sense. It's too big a space to solve. The way that you verify compute has to be very different for different tasks, because different tasks are very different. Machine learning training to us is an incredibly valuable problem to solve. It's not going away. It's getting way, 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 way more important. And it's also going to be happening a lot more. So the kind of future that we talked about with these autonomous agents existing and retraining themselves, we're seeing that already with the big GPT models and things like that are out there. They're trained initially on this big corpus of data, but then they use reinforcement learning on human feedback to improve themselves and to get better. That's going to continue. We're going to get to a continual training future where every model is always training, it's always getting feedback, it's always improving itself. And in order to do that in the most efficient way, you need this substrate of computation that just exists below it, where it can always exist, it can always train. And then you also, interestingly, need other networks. You need inference networks, and you need data networks and things like that. And they're all things we're very interested in, but Gensyn is solely focused on that training slice.
Yeah. I mean, when you think about it, we provide, or Gensyn provides, a superior option when it comes to unit economics and also liberty. But if we just focus on unit economics, the kind of gross margin of Azure, AWS, cloud compute, it hovers around 70% most of the time. So, when we know companies which will raise hundreds of millions of dollars to build machine learning models, they spend, approximately 3/4 of that in terms of in basically giving it to Amazon. On compute, and that's wrong. So when we think about how do we reduce that to zero, which is something that machine learning compute protocols can do because it's just peer to peer, we think about, well, we have to make the cost low. So, but to do that, you have to think about the verification problem, which Ben mentioned. So essentially, just for the listeners, if I asked you, how do you add a series of numbers together on a processing unit, and how can you prove to me that you've done that, in a way which is low overhead? How can you prove it's been done correctly? You might think, well, you could get a bunch of people to do it, and then you could all add the numbers together, and then the consensus can emerge from that, and people who make mistakes can be removed, or you could have some kind of reputation system, etc. Essentially, when we think about that, there are problems which sit below it. So, for example, if you add different numbers together or multiply different numbers together on different devices, you get slightly different numbers.
Yeah.
And like that problem alone is something that we spent so much time on. So, for example, when you think about training a large neural network, there's usually like 4 sources of kind of randomness. You've got like the framework level, where if you're building if you're using, say, PyTorch or TensorFlow, there's just randomness there. Like it will just, use like a different random seed every time. It will introduce and instantiate the model with different numbers. And slightly lower down, you have, what the system parameters of the virtual machine you're using. Are you using the same operating system? Are there any kind of things which might influence the randomness even more, of a determinism? And you go one level lower, and you're like, well, how does this kind of compile and get set to the actual processing unit itself? Because on different, GPUs, it gets done differently, and that also results in very tiny changes. And then even lower than that, you have more abstract things like, bit flips caused by cosmic rays, which is from like the sun, which are like hitting the plates on the GPU, and right. it gets so complicated. And obviously, when you're using verifiable compute, hashing is used a lot, and even one bit out of place ruins the whole hash when you prove for the hashing algorithm. So that's like a kind of core problem we think about a lot. Like, how do you make machine learning reproducible? Because reproducibility is a cornerstone for what we're building. And then, also, as Ben said, like having the ability to take an output from a reproducible system, combine it with a low cost proof, which can say, with very high confidence that this model has been trained correctly, and then combining that with a kind of game theoretic incentive where, you can cheat if you want, you can lie to the system, you can say, the model showed this, but the kind of expected value of doing that's negative because you got more at risk than you're expected to gain. And kind of circling all that up creates a complicated but ultimately ultra low overhead proof system, and it solves that problem of trust.
So you mentioned a lot of things there, and I just really want to maybe package all of it and ask you, how hard is it to build all of this? And given that you're specifically since you've embarked on this journey, it's been what, 18 months, something like that?
A little bit over 2 years, I'd say.
Yeah.
Oh, so 2 years since we have been doing this. You obviously still have a lot of work to do to actually have a complete system. What you need to actually get this off the ground, and especially as founders, you probably think about this all day long, like how to even orchestrate. So there's orchestrating all of these computational marvels in a sense at the protocol level, but there's actually building it at the team level. And that is something that I'm actually very curious about because, well, always am, and I know we've talked about this a lot, but you guys are still a small team, and you probably will need a lot of resources just to get this off the ground, just to bring this to completeness. So tell us a little bit about, what you've had to do to kind of make sure that this gets built. You recently raised a round. What are your plans moving forward, and how can you make sure that you're actually attacking this as aggressively as you can?
Yeah, sure. I think the most important thing to us is to do this right. Yeah. Like there's been teams before that have done general purpose compute platforms like we talked about. They never worked. And one of the big reasons why they've never worked in our view is that they took shortcuts. Like there's a lot of shortcuts that exist on this journey. You can sort of solve this problem in a lot of ways, but all of those ways lead to ceilings that happen very, very quickly. One of the classic ones, for example, is you can use a reputation system. Essentially, you can say, out of all of the nodes in this ecosystem, let's just let the people who send the tasks out rate those nodes, and then the ones with the lowest ratings will fall out because nobody will use them, and they're the malicious parties, and then this whole thing works. Sure. By doing that, you assume that everyone who's sending a task to the network can actually check those tasks. And then you think, from machine learning compute, I'm using this network because I don't have the device in order to do it myself. So that just doesn't work at all. Reputation systems are flawed in other ways. You can Sybil attack them very easily. You can have, like, back in the eBay days, you could have like feedback rings where people would just give each other feedback and get their ratings up and things like that. So there's lots of these shortcuts that essentially can be quite attractive to teams, but they ultimately just limit your scale completely. Our view of how to avoid those shortcuts is to just stay laser focused on solving the actual problem itself. And from a team perspective, doing that, you hire a very small group of very, very powerful people, very accomplished people who can build this stuff. And then you just get your heads down and you build it. You stay focused on the task and stay focused on solving that big problem. And don't get distracted by the things that come along where, hey, maybe there's this like downstream use case within AI where the network that we've built so far could just be used for that and we can make some money doing that. We don't care about that. We want to build this foundational infrastructure and we want to build a team that believes in that. So the team, everybody that we hire fully believes in that vision. They're here because they want to build that thing with us. And our culture is very much small group of people working very autonomously, very little hierarchy, but all towards that shared goal. And then our role as founders is almost just keeping the direction. So you get all of these people in a room and you say, hey, everyone sprint at this problem. And people are going to sprint in slightly different directions. And as founders, all you want to do is kind of like just nudge. You just want to say, hey, let's make sure we're all going in the same direction. But everyone's doing the sprinting. Everyone's pushing things forward. And that's what we think about a lot with the team hiring. It's all about culture. And we've seen so many teams do this where you raise a decent amount of money, you hire loads of people, and your culture entirely falls apart. We're not interested in doing that. We don't want to do that kind of boom and bust scaling where then you have to go back down, you have to go back up. You've lost the culture of the team. You've lost the morale of the team because people don't know what's going on. We just want this small group focused on that task.
And you talked about culture. I think before culture, the thing that leads to culture is the values. And so obviously we talk a lot about this, but specifically for a task as formidable as building Gensyn, I believe that values must be the most important, you could say, direction or flag that you can wave to not only attract these incredible people into your team, but also to keep them in line and to make sure that everybody's still working towards the same goal. So Harry, maybe you could talk a little bit about how you guys have instated this set of values. And I know you guys are very particular, by the way, about these values. You're very particular about how you hire, how you fire, and all these things. And I don't think that's I don't think that's something that I've really seen as deeply in other teams. And so I'd love to uncover that little tidbit with you.
So the kind of first value we had, and the first one we kind of would usually express to people, was this around autonomy, as Ben said. And autonomy means lots of different things. It means, the ability to basically stake ownership on something and not be granted ownership. It kind of goes back to that idea of positive versus negative liberty. But it also means the ability, it has kind of adjacent kind of properties, like the ability to work under extreme sort of uncertainty. You don't kind of need things to be very linear. You're kind of comfortable with non-linearity. You're comfortable with also, I guess, kind of working on things where the payoffs are just like fundamentally like quite hard to quantify. One of the kind of issues we had, which we recently kind of updated, is having values for us kind of was a bit of an impediment to autonomy in the early days. Like the idea of saying to someone like, you must be autonomous, it's just a little bit kind of like the purpose, it's a bit paradoxical. Yeah.
Sure.
So we don't kind of like the idea, like, you use the kind of term like, like keep people in line. That's definitely not our sort of ethos. Our ethos is basically, if people are vision aligned and they're excellent, which I'd say would be our second value, they, and their focus, which is the third one, just to round it out, they typically will arrive at a conclusion which makes sense. And, but the difficulty is, of course, finding people with all three of those values, particularly when you're hiring people who are technically brilliant, but they've not worked in environments which are very exposed to, I guess, the kind of uncertainty which working on applied research problems like this face. It's really difficult. So we hire, versus the applications we get, a very minimal number of people, which is really common for people building in our space. But the number one thing, probably 80% of the kind of rejections are just around culture. They're just around, the person didn't demonstrate the ability to, or like, in their kind of past, like the ability to work in situations where it's very nonlinear, or they need to be kind of given things, or they're not comfortable getting, very direct, kind of continual feedback. A book that I like, and it's a bit like overdone, like, but like Anti-Fragile by Nassim Taleb, where he gives this example of, if you're a taxi driver in New York, you get this kind of like, you're essentially, you have to be autonomous. You're autonomous in a very literal sense, because you're driving a fucking taxi, but like at the same time, you're very sensitive to, are people in this area of Manhattan actually wanting taxis?
Yeah.
Or are they not? And, how do I fix, I will move somewhere else. And you contrast that with like a government worker who, works in their job, say for 20 years. And then, one day, like the government changes and there's a budget cut and they get fired. And it's just kind of binary. It's like, you're either in or you're out. And that's very similar to how we kind of think that the kind of non-autonomous cultures look. People who we see in, like, they often come from very large companies, which are quite bureaucratic. They kind of have that kind of quality, whereas the kind of what we go for, people who have more that kind of taxi driver mentality, where they're continually adjusting based on a kind of fog of war type situation, and they're able to kind of navigate it well. It doesn't mean that they can't make mistakes, of course. It just means that in the situation, they use all the available evidence and like a very clear mind to make the best call. If people keep doing that, then the only remaining factor is basically luck. And, I don't believe people are naturally unlucky. So,
well, yeah, there's a couple of instances.
Well, maybe
we don't get into that. No, but actually, on the point of on your point regarding values, I think that specifically given the fog of war that you're in, communicating those values through action is always better than writing them on a wall in your office, or
100%,
or repeating it as a mantra at the beginning of a meeting or something, right?
Yeah.
And I think that you guys have really I mean, just seeing how you've worked and seeing how you've done what you have over the last 2 years is to me a really strong testament that of, look, leaders lead from not from behind, that's for sure, and always from the front. And I think that there's this idea of, leading through action and instating those values through just how you are rather than what you say is extremely important. And specifically in your case, it's worked very well for you. Ben, do you have any additional thoughts just on you could say the application of values within the fog of war that you're in?
Yeah. It's something we've thought about a lot. And to be honest, we were almost hesitant to like say the values here because we think as soon as you create or you make values a metric, you kind of completely weaken the impact of those values. Right. We kind of realize that you do have to sort of maintain the knowledge of the value itself. You have to kind of self-reinforce it. But like you said, put it up on the wall. Everyone walks past it every day. Everyone can point at it and say, hey, we have integrity as a company. And it's like, it's meaningless, right? Like it doesn't mean anything. I think, like you say, you have to demonstrate it constantly. One of the biggest things I think we see with a lot of the candidates that we look at is that people will put barriers in front of themselves like all of the time. And that's like probably one of the biggest dangers to the autonomy value is that people will come in and they'll just assume that barriers exist. And people do this constantly. People do this in their personal lives. People do this in their work lives. It's all the time. But so often those barriers are artificial. And I think when you've kind of gone through the founder journey, you're kind of like relentlessly hit in the face with the fact that those barriers are artificial because you constantly go past them. If you're like, hey, yeah, I'm never going to be able to raise this round because like the ecosystem's not as strong right now, like COVID's happening, it's not going to happen. But you're like, okay, fuck it, I'm going to do it anyway. And then it works. You're like, okay, that was a false barrier. And then you just keep going through them. You keep going through them. I think as founders, it's demonstrating that keeps happening, like identifying that this might look like a barrier, but we're going to smash through it. And that everyone in the organization should be doing that as well. But yeah, when you've been at like a very, very large org, you are used to other people putting those barriers in front of you. And then you might think, hey, that exists for me. I can't do this. I can't like put myself out my comfort zone, or I shouldn't take ownership of this because somebody else is going to do it and I'll just let it happen. So yeah, it's definitely something we see in the candidates, and it's something we want to kind of like demonstrate from ourselves that, look, this doesn't exist. That like, yeah, functionally there are no barriers. Like, just go out and do it. Like, we're not going to be a barrier to you. And I think the failure thing that Harry mentioned is really important. Like, you need to be free to fail. You shouldn't be failing because you're negligent. Like, that's not good. Like, you need to be excellent, which is another one we talked about. But if you're failing because you took a bet on something in a massive amount of uncertainty, did the best that you could, and it turned out to be the wrong bet, like, that's fine because you moved, you pushed forward and you did it. And that's what we want. We want people who are going to do that. They're going to put themselves out there, take ownership of an area, say, I don't know what necessarily the best bet is here, but I'm going to do this and I'm going to see what happens, and I'm going to do it to the best of my abilities. And we've seen that in the team so far, and it's been amazing. It's been really impactful.
In many ways, like, nature is failure, when, like, if you think about the kind of, all of your ancestors, there were people who took different routes and failed, and, and maybe they're not reflected in the kind of in society today as a consequence. But it's the same with like building startups as well. You make bets, and when we think back to the accelerator, for example, which is a very kind of, I would say, like, Darwinistic place, it might be Love Island or whatever, but like it is quite the outcomes are very Pareto, right? There's a few who kind of, it's kind of winner takes all. Loads of those ideas were, like, at the time, like, definitely of the other companies we were with, number one, amazing founders, number two, great ideas, number three, markets were there, and it all made sense at the time. But then it just doesn't work out because you slowly build more, you raise a bit of funding, and then you realize, actually, what I thought was here at the time and I was completely legitimate in believing was there isn't there. The market's not as big, like the product actually doesn't do as much as I thought, etc. And that's fine because that adds to the kind of body of collective capitalism where people are like, okay, well, this was tried and it failed, and okay, let's try something else. Whereas if you have these kind of really tight, sort of constricted environments, which are very artificial, where, if you fail, you're out, that's generally not very productive. So yeah, I think taking that approach is important. I would say though that, there are certain kind of roles which are just inherently more like risk averse. If you're hiring like a chief compliance officer or something. Like, you know,
I can't let them fail too many.
yeah, you know,
Let's break it.
yeah, they're not rolling the dice every morning, like, which is, you know, fair enough to an extent. So there's definitely like levels to it. Yeah.
Sure. Moving topics, maybe just zooming out once again. I think that we really were able to just touch on the kind of the need for something like Gensyn, specifically when it comes to artificial intelligence compute. Now, something that I'd love to just uncover with you guys today is really just how what all of this spells out when it comes to the opportunity. And you were talking about, Harry, you were talking about the unit economics of just how it makes so much sense for folks to actually utilize something like Gensyn, a protocol like Gensyn, then go and pay Azure or AWS exorbitant fees just to actually have access to this kind of computation. And so I want to maybe ask you guys, with Gensyn in the picture, how do you think about the progress of this market? How do you think about the growth of the market that you're now in? And specifically, I mean, let's just be clear about this. We've been seeing these $1 billion rounds, or, you know, in valuation, or hundreds of millions of dollars raised by these companies. And the first thing that I see when I see these, that I think about when I see these companies, I'm like, well, first of all, great for them. But second of all, great for Gensyn, right?
Sure, right.
Because in a sense, each and every single one of these companies that ends up paying 80% of what they raise to AWS, in a sense, has a lot more with Gensyn in the picture. So I really want to talk about, with Gensyn's position as an enabler, how do you see the growth of this market?
Yeah. When we think about it, we think firstly and foremost, you know, the market is the market for machine learning compute, specifically for training. It's estimated that by roughly 2031, it will be larger than 1% of US GDP, which just like is a staggering number, you know, and it's growing exponentially. I think the number is probably conservative, but it's huge. That's the first point. The second point is technology is generally deflationary. So when we think about the various like industrial revolutions, you could start back with steam, then, you know, you move to electricity kind of in the home like 100 years later, and then, you know, 100 years on from that, you have the internet. It generally pulls down prices significantly, you know, whether it's messaging, you know, how much did it cost to send a message between London and New York in like the 1700s versus, you know, today, or whether it's the, you know, the ability for transport. So for example, like the Bessemer process, when in steel manufacturing that Andrew Carnegie kind of popularized, it made it so much easier to build railroads, and railroads connected America. And, you know, okay, there were lots of like issues in that time with people like having like raising money for scam railroads and stuff, but like ultimately the effect it had on society was deflationary. Things became cheaper, and as a result, people moved faster. And we're right at that inflection point again, where we have this revolutionary technology. You know, the next industrial revolution will be one of compute, and we have a way to make it substantially cheaper, where essentially, if we can remove those margins of around 70%, you're more or less like 4 to 5xing the bang for buck on $1 of venture capital raised, or, you know, $1 of kind of capital spent on training these models. And the effects that will have will just be, I mean, they're hard to calculate. You know, in the next few years, we're going to go to a point where when you watch something like Netflix, everything will be generated on the fly. People will license out their likenesses. You could say, you know, one of my favorite movies is Blade Runner, and I could just say, put me in Blade Runner. Make me, you know, Rick Deckard, make me the main guy. Yeah, and, you know, maybe make it like, you know, a little bit more romantic, or, you know, instead of it being raining, make it snow. And of course, you know, there's value flows there, you know, who gets the rights to that, etc. Lots of these kind of questions to be worked out, which incidentally is an enormous economic opportunity in itself. We discussed that another time, but like that's a whole other thing. But, you know, that's one thing. So the idea that we talked about brain-machine interfaces, where right now you have this world whereby, you know, when we were growing up, you had the kind of like the proto-internet and stuff like that. That you could search for information, but it wasn't kind of in your pocket in the same way that it is today of Google, etc., or indeed GPT-4. If you wanted to, you know, remember something, you kind of had to remember it. However, today, you don't really need to remember everything. It's basically like a few seconds away via a phone. That kind of latency, similar to how we think about sending messages between, London and New York, is actually going to reduce even further, where with a brain-machine interface and a, compressed neural network in the interface, or an ultra, low latency connection to the internet, you can actually just query things with your mind immediately. And that has a huge force multiplier on the ability for human progress. Imagine you could just query the internet as easy as you can think. The result of that economically is just unfathomable. Like it's just so hard to.
I think we're already starting to see some of the effects of that with the power of like ChatGPT and the other chat models, right? Where they become this much higher bandwidth connection to the data of the internet. I think there's a really interesting kind of like social evolution, because it's not kind of like true evolution, but in how people deal with storing information, like Harry mentioned. Like we've gone from, and the studies on this, you can see this in like children and in new generations, where you remember the query terms to retrieve information rather than remembering the information. So the way our brains work now, having like kind of grown up with the internet, is that we remember the kind of keywords. We don't need to remember the true information behind it because we know it's always available. With the chat models, we start to remember the way that we need to interact with something and what we need to say in order to retrieve that information. At the moment, that's kind of still via the internet. It's via the kind of hive mind. But what we're going to get to with the kind of compute being more available, with the data and attribution being done properly, with all the authenticity and identity done properly, we can move to having personal models. And for me, that's the kind of most exciting thing about all of this, because personal models, in my mind, represent the augmentation of the human mind. They're kind of offloading our memory and putting it somewhere else. And that's the way that we increase. It's almost like putting more RAM in your brain, right? Or it's putting an SSD next to your brain and saying, hey, now I can access all of this information as well, but I just need that interface to be able to do it. And these models can be that interface. So like Harry mentioned, you can have the physical interface itself, like the brain-computer interface, or we can use speech or something like that. But in order to get the information translated, we have to have something that can kind of condense that information into something that's really rich, some kind of embedding of all of the data so that we can like traverse it really quickly. And that's what these AI models are. There are ways to condense all that information, put it in some kind of like latent embedding space, and then move through that space very, very efficiently. And yeah, through the chat models, we're doing that right now. Speech is much higher, much lower latency, much higher bandwidth than if we're like typing or if we're writing. But there's more exciting things. There's like the brain-computer interfaces. There's just getting closer and closer to the brain itself that make that even more possible, basically.
And when you think about that, you think, if you kind of listen to this so far, you think, okay, so we're in this kind of position where we're kind of querying via a language model connected to our minds, the body of all human knowledge. Do you want the person who's, you want someone to be one person or a small group of people in, San Francisco to be deciding how that model interprets your thoughts and what it gives back to you?
And how do you make that person give me more money?
Yeah, exactly. It's so kind of.
Well, that's quite dystopian.
It is dystopian.
Yeah.
That basically, it's someone's basically in your mind at that point.
Right.
And it obviously, maybe some people listening to this think, well, the idea of me having a brain-machine interface is kind of dystopian, just to begin with, right? And
but maybe it's not with open systems, right?
Well, that's the thing. I think that the idea is that the open systems and the kind of computational liberty that comes with using a machine learning computer protocol for the low cost and the permissionless access basically allows everyone to build their own model and everyone to have sovereignty over their own thoughts. And, to some people, this might sound a bit like abstract, but the rate of technological advancement we have, in the world today is so fast that we're going to get to this point, imminently. If you just look at some of the adjacent things around machine learning, most notably something like nuclear fusion, people think, okay, well, it's a compute problem. Compute's basically putting electricity through transistors to add numbers together or multiply numbers. And you think, okay, well, what happens if the price of the electricity drops, by an order of magnitude?
Right.
Like that's one thing. And then on the other side, you have the kind of the cumulative benefits of if you've got an artificial general intelligence, something which basically reaches parity across the majority of, relevant dimensions of a human being. Suddenly you've got something which can rapidly retrain itself and reach a kind of super, intelligence state. At that point, you've got almost another species which is significantly smarter and can, I guess ostensibly be kind of queried and ask questions, how do we solve this hard problem we can't solve as humans?
Right.
I mean, that's a force unlock. So it just ends up looking so exponential, which is number one, why it's so exciting, but number two, why we have to enshrine the kind of core, Western concepts of liberty at its foundation.
I think those points around sovereignty are really interesting as well, because they're things that people have thought about a lot, but you can't go directly to that because typically in the kind of markets we exist in right now, there isn't a value proposition behind that. It typically makes things like slightly more inefficient in itself in order to enshrine that sovereignty. There's been loads and loads of attempts to say, hey, the world would look better if we had this like data infrastructure that was like better for the individual and things like that. Like, that was what I used to work on in my previous startup. It was very ideological, very philosophical. We want to get to this state of the world. I think what we've realized with Gensyn is you have to have a value proposition that's outside of that, but you can get that as well. It's like a kind of side benefit to what you do. And that's what's so interesting about blockchain protocols, because if you can find one that has a key value proposition that exists far away from the ideology, it makes compute way cheaper. It makes compute way more accessible. It solves a problem that just exists in the world really well. As a side benefit, you get all these benefits of decentralization, and it gives us a way to get over here, to get to those sovereignty points without having to try and sell those individually to every consumer, because ultimately it's a very hard thing to do. The education piece itself is hard enough, and even then it's still saying, hey, we want to put more friction in front of you for a benefit that's kind of abstract. Like, it's people don't really understand the benefit.
Yeah, it's hard for people to swallow the ideology pill without any practical positive impact on their lives. Right?
Exactly. Totally. Yeah. And I think like if it kind of zags the kind of crypto dimension really well, like like Bitcoin, to many people who don't use it every day think, it makes sense, but they don't still use it every day. There's this kind of like, like in joke in crypto where, a lot of people don't even use their own products because it's just, just rather do a wire transfer or whatever, right? Use PayPal or something because it's just easier, right? So you have to make it, it has to be something which pulls people in on the kind of on the unit economics and on the access, which is kind of where our first priority is. But it comes with this, really kind of open source, philosophy of computational liberty. And then just to kind of close off on your question about like the wider, the benefits it has for society. Something I'm really excited about it with is medicine, because I think like as a society we've kind of institutionalized and regulated medicine to the point where it's like in the United States it's extremely expensive. In Europe it's essentially inaccessible in many cases, huge wait lines, etc. There was a kind of concept in the Cultural Revolution in China around the idea of barefoot doctors, where basically it became clear that lots of villages needed doctors. There weren't enough like university trained doctors to go around, so they got individuals out the villages. They gave them a 1 or 2 month course where they taught them the basics of medicine and sent them back into the villages, and essentially had a very kind of deregulated form of medicine. This has been happening slowly since the origin of the internet, where people just Google their symptoms, and it's pretty culturally acceptable. Like, I ask Google and it says I'm this or that, and that's lowered the cost of access to medicine in a kind of slightly subtle way when you think about it, because you might have had to go to a doctor previously. I think large language models are the logical next extension of that, where you can essentially encode a doctor in a model, and the cost of accessing the doctor is a fraction of a penny. And to get there, it might require us to say, well, anyone can build a doctor model if they want, and they can use that doctor model. Would you rather someone have to wait in line for 2 months to see a doctor, pay $10,000 to get the kind of regulated access, or maybe have like a 90% equivalent access via a kind of, Dr. GPT type situation, which is an open source doctor model? I think it's unfair on the people who can't bear with the first and second option to limit them to have the third option. So it's one thing I always think when people talk about limiting and regulating AI is how they answer that question. What do they say about that third category of person in the world who isn't, doesn't have the time to wait because maybe they've got like a symptom which is really bad, doesn't have the money to access, or indeed perhaps lives in a part of the world where there isn't actually, just access in general.
Yeah, I think that actually speaks to a final point that I'd love to maybe explore with you guys, which is the idea that when it comes to these new technological paradigms, there's often the question of who will win out of this, right? who's the biggest uh, group of people that might profit from such a paradigm shift. And I think that in the current world that we find ourselves in, specifically in the case of AI, it's almost as if it's an obvious that the big tech companies, the governments, and the select few who have this kind of authority over this compute will be the biggest benefactors of these paradigm shift. I think that there's this fundamental question around, can we bring these technologies? And of course, I think that, privacy technologies, as well as blockchains in general, the idea of decentralization is to actually bring value back to all stakeholders in any given governance model or any given financial system. And I really think that the missing piece for the largest benefactors to actually be those, the weak, the people that most need it, is actually something like Gensyn. And so I'd like to maybe uncover that with you guys just a little bit. Do you believe that right now the average person is the largest benefactor of artificial intelligence without Gensyn? Like, paint the picture to me, because I think that's a question that I ask myself a lot.
Yeah, I think you're right. Like the largest kind of benefactor right now is the large organizations. Like they have this kind of like centralized control over so much of the resources required to do this, that any kind of usage and revenue and things that flow to that gets captured at these layers that essentially sit on top of it and then gatekeep all of those resources. So that exists at the kind of like cloud provider level, where they've hoovered up all of the GPUs, they've got access to them, and they say, hey, only you can access these and you have to pay us huge amounts of money. But it also exists at the modeling level, where there's a very small number of companies that can build these models. There's a small number of companies that can then give out access to those models and take the revenues that come from that. And I think when you look at that, you think, right, well, that resource at the bottom, the kind of data, it's the people's data that's being used, right? The hardware resources, like we can go out and buy GPUs, theoretically. And the expert knowledge is out there. Like we talked about some of the issues with the kind of academic publishing world earlier, but it is very good at like disseminating knowledge. And you can go on archive right now and you can read a paper that tells you exactly how to build one of these models. You can get the data's openly available. You can get access to that. You can't get access to the GPU, so you can't build that model. But if you could get access to the GPUs, you could build like a competitor to one of these language models, and you could put a nicer interface in front of it. There's many ways you could take some market share away from those large organizations, and you could have a perfectly valid system, and you could capture some value from that. But you're not able to because of these kind of like strangleholds on resources. One of the things that the crypto networks do very, very well is cement value flows that go right the way back down to the core resource. So if I'm able to hold that core resource, I can put it out for sale and available to other people, and I can get a fair share of the usage of that resource. So my GPU is just as valuable as everybody else's GPU in this network. My data is just as valuable as everybody else's. My knowledge is just as valuable as everybody else's. There isn't this kind of layer in front of it which might tell me at the start that it's just as valuable as a way to get me to provide my resource. But then over time, it's going to be incentivized to say, actually, I need to capture more profit. My shareholders are saying you need to be making more profit as a company. So I'm going to kind of trim down what I pass to that person because I'm able to do that. I have those controls. If you build a protocol instead of a company, there's no way to do that. The protocol can be governed by a group of people who are the people who hold the resources. And then they can keep that enshrined to say that that value flow should continue to go all the way back down to the core resources. You have each resource represented in the governance of that overall protocol. And that thing can last forever. I think that's the most exciting thing to us. When you build a company, you go through this kind of flow where you start out kind of as the nascent player, then incumbent. You need to disrupt them. You'll do lots of things to disrupt them. You can bootstrap, you can get lots of cash, you can subsidize. Once you get enough market share, you move into monetization, and then you become the incumbent. And then somebody else can come along and can disrupt you. And that's a model that it works reasonably well through competition, but that's a stage where you become the incumbent and very large. You're kind of incentivized to create a monopoly and then hold that monopoly. And that's the bit when it's very bad for everybody else involved. By building a protocol, you never get that stage. The protocol just needs to maintain itself.
Well, you never
It
get a
just needs to
monopoly because everybody's incentivized to be a part of it.
Exactly. The protocol never becomes a monopoly because it never needs to increase prices. It never needs to put a stranglehold on the core resources. It just continues to exist.
It never needs to shut down competition. It never,
Exactly.
Right.
And there's no reason for there to be competition because there's no profit margin. So the only money that needs to go to that protocol is just enough for it to exist. And then somebody could come along, they could fork it, they could have value that's different to that protocol, they could take away the share, but it won't be because they've put profit on top of it and they've kind of strangled their users and their resources. It'll be because just it's better, right?
And this is also where we see this kind of practical, I guess, increase in quality of life and in financial outcomes, and for everybody that has to do with any given technology, right? And so maybe going back to my question and your answer as well, I think that we're in a place where I mean, this could be dangerous, right? This could be dangerous for the world, for the weak, for the folks that might actually be the biggest benefactors of this technology. And I see Gensyn as this kind of central piece, this fundamental layer where all of this could actually happen, where having a brain that is connected to a computer wouldn't sound so dystopian sometime in the future, thanks to decentralized systems like Gensyn, like what you guys are building. As a final kind of point, do you guys have any ideas or things that you're particularly excited about these days that you think specifically maybe looking into the next few months? What are you guys most excited about, just in terms of what you're building, in terms of what you're learning about? It could be anything.
Yeah, I think launching the first version of the testnet is the most obvious one. So like for us, launching that first version of a network and actually seeing it come to fruition is a really core one, because I think like it can get to the point where things make kind of sense in an abstract way, but actually seeing it out there and using it is really core. I'm also really just excited to see the increased kind of growth in the open source machine learning models which are out there. Mm-hmm. I mean, because it kind of all this kind of recent boom in AI kind of started with the generative image models,
right,
like last year, and people like with Stable Diffusion to a large extent kind of ushered that in. And they've just been getting so much better, right? It's getting to the point where an individual actually can basically have an entire sort of digital animation studio. And I personally am a huge fan of science fiction, and there are a number of books which I would just love to see brought to life in a film.
Apart from Blade Runner, what are some of your favorites?
The Moon is a Harsh Mistress. Nice. By Heinlein. I think like on the kind of more like pulp science fiction side, I love Warhammer 40,000. So I read tons of those kind of books. It's not really like kind of high sci-fi though.
It burned a hole in my pocket when I was just buying all the models. So yeah.
I think Do Androids Dream of Electric Sheep would be way up there as well.
So you'd want to bring all of those to life.
Yeah, I mean, Androids got brought to life by Blade Runner, but they're just so many like interpretations of it. I mean, the movie's so different from the book. Like that's the other thing.
Yeah.
I mean, like Neuromancer. There's never been a Snow Crash movie. All these are like
criminal.
all these are like such like just some people from listening is probably rolling their eyes with some of those suggestions because they're so like typical, but like at the same time, like they've never been made into films, right? So it's kind of like we're really missing out. And I guess there's a side point, which is actually, I think, happening currently, where you can take books, kind of classics typically, which haven't been turned into audiobooks and make them audiobooks. So I personally love audiobooks as a kind of medium of listening. And, it's a subset of the overall library of books that exist. And right now we have the ability to transform them into audiobooks, which is just incredible, Yeah. So being able to transform those books into movies is the next big one, I think, which is going to be good.
Cool.
I think one of the things that you when you do bring down the cost and like the availability of the resources so much, you enable a load more experiments like that, right? Because we've at the moment, like, because it's so expensive to build anything within ML and AI, you have to be incredibly certain that you're going to be able to make enormous amounts of money from it because of the investment that you've put in.
You have to be too selective.
Exactly. So you're like, oh, I'm going to turn this book into a film, but like, is that going to be really that popular? Like some of the more niche ones, you're not going to do. Whereas if you like bring down all of those costs, you get people to come along and be like, I'm just really passionate about this thing. I'm going to turn it into a series or whatever. It's just way more experimentation rather than this kind of like pure go straight to something that I definitely know is going to be like successful and everyone's going to love it. And those like niche kind of like sub communities being able to experiment and build like weird models and do weird stuff is where you get the kind of like true like outlier stuff happening, which I think is really exciting. But I definitely mirror Harry's point about wanting to get something out into the world. Like you mentioned earlier, we've been building for a long time. Like we've been doing a lot of research, and when you do that from like a deep tech perspective, you can get in this kind of like situation where you feel like you're kind of building this cathedral with like nobody looking at it. And then at some point you unveil it to the world, and there's a chance that people are like, "What the hell is that?" Like, I don't want to use that. Like,
what a scary moment.
Yeah, exactly. Yeah. So like just getting that feedback, and I think we're going through a shift in venture capital right now, where it's kind of like we're upweighting again, like how valuable it can be to actually spend a lot of time and like really build something properly. But you still need to test the market. You still need to go out to people and say, is this like something you're going to use? Like, is the friction from what you're currently doing low enough that you will switch to this? And that's something we want to test. And that's something obviously we'll see as soon as we get something out there. We've got loads of people who are very, very keen to use it. And I guess if anyone's listening and wants to like build these models that we described and wants to experiment with things or wants to provide like GPUs and resources to the network, we're super open to people approaching us to do that. I think with the open models point that Harry made, at the moment we're getting loads of these really cool open models released, and like the architectures are out there and the weights are out there, but the resources to run them are still very hard to get. Gensyn represents like the kind of removal of that final barrier. So if you do want to focus on truly open models, an infrastructure like ours is required. So you take one of these big open models that one of the huge tech providers has built, and you distribute it out over some GPUs that like the community holds. And we're really, really keen to do that. So if people want to do that, like please come to us. We'll talk to you and we'll make it happen.
Yeah, I'd also just add to that in terms of the audience. If you are a machine learning engineer, GPU engineer at a large company, and you're number one, exceptional, but number two, you are kind of looking for something substantially different in terms of the way the company is governed and also the kind of autonomy that you're provided, then please do apply. Like we definitely aren't kind of like against hiring people from large companies. There's so much value there, and there's so many people that I know want to leave, particularly right now. So.
yeah.
There's another option available.
Yeah, it exists,
and it's a hell of an option, guys. Thank you so much. It was a really, really wonderful time speaking with you. I think you've educated me once again on your vision and what's in your heart. So thank you. And I'm excited to be doing this again in a few months' time, because I know that things are going to be pretty different once again.
Absolutely. It's a pleasure.
Yeah, thank you.
Cheers.